In this video, we are going to go over the area of regular polygons. So, things we need to know, the first is our radius. Our radius goes from the center of the polygon to the vertex. So the vertex is that angle. So we have that highlighted. It is that side length of 30, and as we can see, it's at that corner. The apothem goes from the center straight down to the middle of an exterior side. So if we see it go straight down, it forms a 90-degree angle. So our formula for any regular polygon is the area equals A times P divided by 2, where P is the perimeter around the figure and A is our apothem. Now, things we need to remember about the regular polygons is that all exterior sides have the exact same length. So for this example, if one side is 36, there are 5 sides, so 36 times 5 equals 180. Now for our apothem, we need to use the Pythagorean theorem. We have the radius, which will be the hypotenuse of our triangle, is 30. Our apothem is one of our legs. We need to figure out what that base is. So if the whole thing is 36, it is cut in half, so that base is going to be 18. So we have a squared plus 18 squared equals 30 squared. So subtract the 18 squared over, take the square root, and we get that our apothem is 24. So now that we've calculated the perimeter, we found our apothem, we can plug it into our formula and find the area. So area equals 24 times 180 divided by 2. So our area for this one is 2,160. As you can see, we don't have any units on this example, so there's no units in our answer. So looking at these examples, this first one, it gives us the apothem. It goes center straight down, so we don't have to do any extra trig. We do need to find our perimeter. This polygon has 6 sides, so 24 times 6, we get a perimeter of 144. So plugging it in, 22 times 124 divided by 2, our area is 1,584. Now for this next example, if you notice, we do not have the apothem, we have the radius. We're going from the center out to the vertex. So we do need to use Pythagorean theorem. And half of our base is 24, so that's what we'll use for our triangle. A squared plus 24 squared equals 40 squared. Subtract the 24 squared over, and then take the square root. We get that the apothem is 32. Now we also need to find our perimeter. One side is 48, and we have 8 sides. So 48 times 8, we get 384 for the perimeter. So we can plug 384 and 32 into our formula. 32 times 384 divided by 2, we get an area of 6,144. Now, these look a little different. We only have our bases, so we don't have the radius, and we don't have our apothem. So in these, we have to use the other kind of trig we talked about in our area and trig video, which is SOHCAHTOA. So the first thing is we got that 30 degrees because in an equilateral triangle, all angles are 60. That angle is getting bisected, so we have 30. So we can set that up. A is our opposite, 4 is our adjacent, so we're using tangent. So tan of 30 equals A over 4. Multiply 4 to the other side. 4 tangent of 30 is 2.3. So our apothem is 2.3. Now to find our perimeter, we have 3 sides, so 8 times 3 is 24. So let's plug in our apothem and our perimeter. 2.3 times 24 divided by 2, we get an area of 27.6. Now for this one, we have to kind of refresh ourselves, finding the angle measure of every single angle in a regular polygon. That is 180 times n minus 2, all divided by n, where n is the number of sides. So to find our angle measure, we would have 6 minus 2 times 180, which is 4 times 180 divided by 6, we get 120. Now remember that angle is getting bisected, so we're only using half, so our angle is 60. So now we have our right triangle, A is our opposite side from that angle, and then 9 is our adjacent. So we're using tangent of 60 equals A over 9. So A equals 9 tan of 60, which gives us 15.6. So we have our apothem. Now we need to find our perimeter. Each side is 18. We have 6 sides, so 18 times 6 is 108. Plug those values in. We have 108 times 15.6, all divided by 2. And our area is 842.4.